Now we're going to talk about stacks and queues in C++. Now before we delve into coding, let's understand the concepts of stacks and queues. A stack follows the last in, first out principle, or LIFO, where the last element inserted is the first one to be removed. On the other hand, a queue follows the first in, first out principle, where the first element inserted is the first one to be removed. Let's start with the implementation of a stack in C++. In this code snippet, we include the IOStream and stack header files. The stack header file provides the necessary functionalities for implementing a stack. Now, inside the main function, we create a stack called myStack using the std stack int syntax. To push elements into the stack, we use the push function. In this case, we push the integers 1, 2, 3, 4, and 5 onto the stack. To access the top element of the stack, we use the top function. We output this using std cout. To remove elements from the stack, we use the pop function. In this example, we pop 2 elements from the stack. To check if the stack is empty, we use the empty function. If the stack is empty, we output stack is empty. Otherwise, we output stack is not empty. Now, let's move on to the implementation of a queue in C++. In this code, we include the IOStream and queue header files. The queue header file provides the necessary functionalities for implementing a queue. Inside the main function, we create a queue called myQueue using the std queue_int syntax. To enqueue elements into the queue, we use the push function. In this case, we enqueue the integers 1, 2, 3, 4, and 5. To access the front element of the queue, the element that would be dequeued next, we use the front function. We output this element using std cout. To remove elements from the queue, we use the pop function. In this example, we dequeue 2 elements from the queue. To check if the queue is empty, we use the empty function. If the queue is empty, we output queue is empty. Otherwise, we output queue is not empty.